Hello, ratios are used to compare two quantities to one another. In this situation, we're comparing shaded balls to unshaded balls. Shaded to unshaded, there are 1, 2, 3, 4 shaded compared to 3 unshaded. Now, if you were to say that there were a larger bag of balls and there were perhaps 8 shaded balls, and it's still in the same ratio as 4:3, you might think, I wonder how many unshaded balls there must be. Now, equivalent ratios is whereby whatever you do to one of those terms, times it by 2, you must do to the other one as well. Therefore, if there were 8 shaded balls, there would be 6 unshaded. So, ratios can be used in a similar way to fractions in terms of finding an equivalent ratio by doing the same thing to either side. Remember about ratios is that you'll always want them to be whole numbers. So, this example up here, 160 centimetres to 0.3 metres, you've got a decimal. We need it to be a whole number. You can also remember O for order. You don't want to muddle these up. Make sure that they remain in the same order at all times. S means simplify. We want them to be as simplified as possible. We want to think, what is the highest common factor that we can divide both sides by so that it's as low as possible terms. And U for units, you don't want to include the units in the ratio. At the moment, we can't take them out because they're different to one another. So we need to make sure the units are the same so that we can allow them to be different to one another. Looking at this ratio above us, we've got centimetres to metres, we need to make them the same. At the moment, 0.3 metre, that's a decimal, and we don't want decimals, we need them to be whole numbers. So let's change 0.3 metres to centimetres, 0.3 times 100. Okay, there's 100 centimetres in a metre, 0.3, jump the decimal twice, that's 30 centimetres. We have allowed for the units to be the same, 160 to 30. And we don't need to write centimetres because the units are now the same, we can remove them. Let's try to simplify this, and noting that I'm keeping it in the same order every time. Let's divide both sides by 10 to begin with. If we divide both sides by 10, we're left with 16 is to 3. Are there any common factors between 16 and 3? No, there are not. So our lowest ratio, our most simplified, instead of 160 centimetres to 0.3 metres, is 16 to 3. Ratios are often used to share fairly into an amount. It might be to do with cordial, how much cordial versus how much water is used. It might be to do with dividing a prize evenly. Let's say that Riley bought a scratchy along with Dylan. Riley had $4 in his pocket and Dylan only had $1 in his pocket. Therefore, whatever prize money they may win, they should share it in a ratio of Riley to Dylan is 4:1. Okay, so that they get a fair amount of money back from their winnings. Now, from this $5 scratchy, they actually won $32. So, how much should Riley get and how much should Dylan get? Let's consider these 3 steps. Whenever sharing into a ratio, you always begin with addition, move on to division, and end with multiplication. Now, the addition step requires you to think, how many parts are there altogether? Okay, so out of the 4 and the 1 on the ratio, there are 5 parts that this prize money should be shared into. Okay, or 5 parts that we need to work out what each of those parts are. Knowing that there's 5 parts, let's think, how do we know how much one part is? If there's $32 prize money, and there's 5 parts altogether, we can undertake division. 32 divided by 5 to find out what one part is equivalent to. 32 divided by 5, 0, 6 times, carry the 2, put the decimal up above, 6.5 fits into 24 times, 6.4. One part is $6.40. Okay, so if you used $1 towards that scratchy, for every dollar you deserved $6.40 back. Now, Riley actually gave $4, Dylan did give $1. So let's think, Riley to Dylan, Riley gave $4, Dylan gave $1. How much do each of these guys deserve back? Now, Riley deserves 4 lots of $6.40. 4 lots of $6.40, $6.40 times 4. $25.60. And my question jumped in twice for the decimal, and my answer does as well. Riley deserves $25.60. Dylan, he gave $1. He deserves 1 part back. Dylan deserves $6.40 from the winnings. Therefore, if you're dividing $32 into a ratio as 4:1, 4 parts is $25.60, that's what Riley earns. 1 part is $6.40, and that's what Dylan earns. You could double check to make sure that this does actually equal $32 so that you haven't made any errors. $25.60 plus $6.40. Let's check that I haven't made a mistake. $5, $12, $32 all up.